All right, so I'm pleased to introduce our next speaker, Rick Gay from the Arizona Department of Environmental Quality. He works as a Water Quality Standards Project Manager and has done so since the year 2017. He spent 30 years in the water quality field. He's worked for a lot of different water quality agencies in Colorado and Wyoming, and as well as in New Mexico. So he's going to give us a perspective on the challenges surrounding nutrient standards in western states. And so thank you, Rick, for coming.
All right. Thanks for having me. Not many people want to talk about water quality standards because it seems like a little bit of a black box. And seeing all this great research that I've already seen and management techniques and things, this may seem a little off topic, but setting standards in western states has been a challenge. DEQ, our DEQ, has had nutrient standards since the 1980s. Believe it or not, we were one of the early adopters, although you'll see that they may not be exactly relevant. DEQs are responsible for the protection of human health and the environment. To do that, we set standards that can be added to permits, which set limits on the amount of pollutant that they discharge into a watershed or into the environment without having deleterious effects on humans or the organisms that are exposed to that. So that's a pretty fine point, really. And what I'm going to do is give you a pretty high-level view of the other standards groups that we do, like human health, aquatic and wildlife, ag. And then I'll end up discussing nutrients. In general, the other standards are a little bit easier to establish because we can tell how much pollutant the organism can take. We can measure it before it becomes deleterious, and all the variables is consumption rates and things like that. So real quickly, I'll take you through that, then I'll focus a little bit more on nutrients, and then I'll finish up with the direction that most of the western states, we recently met with other DEQs in the West in December and had a chance to visit with each other. And because we thought we all had our own problems, why can't we set nutrient standards? We've been trying since the 80s. And we really got trying hard in the early 2000s, and we still can't get EPA-approved standards. So, because it moves too much. I mean, there's too many variables. But anyway, give you a quick overview. Here's what I consider the easy one, human health standards. It's basically toxicity versus consumption rate, average body weight, and the acceptable cancer risk, which it happens to be 1 in a million. We're okay with 1 person out of a million catching cancer from the exposure to the pollutant, unless you're that one person. I'm sure you'd probably be okay with that. I don't want to dig in too deep. Reference doses, body weights, relative source contribution, but these formulas, except maybe for fish consumption, where this is the human consumption of fish, to which there are different feeding levels required. They accumulate pollutants at different rates. So this is what I call the easy button one. These are all measurable. They're endpoints. We can do research, and the cause effect is really clear. Aquatic and wildlife standards, a little bit more difficult, but generally they will just follow magnitude, meaning the concentration of the pollutant in the environment, how frequently is exposed, and that duration of exposure. Again, good, solid math that we can take a look at the sensitivity to the pollutant by this particular species, and then we'll analyze 8 different species groups and then usually establish a standard based on the most sensitive species, which in Arizona typically ends up being an endangered species, which makes it even more difficult. But because we can't harvest those and test them to see how much toxicity they can take. Our metals get a little more complicated because their bioavailability is impacted and affected by different physical factors in the water column, like hardness, pH, in this case dissolved organic carbon, changes the bioavailability of aluminum to the organisms in the water body. So I know these all are pretty straightforward, again, measurable endpoints. But one thing we struggle with when it gets to nutrients is, this body knows very well, the nutrient phosphorus and nitrogen in it itself are not toxic to us or animals, the organisms we're protecting. However, they do create a chain reaction or creates anoxic conditions and algal blooms, hazardous HABs now, the cyanotoxins, but the relationships of the amount of phosphorus and nitrogen in the water column influenced by temperature, mixing, ultraviolet light. There's many things that aren't as easy to measure, so we're having a lot more difficulty establishing what those are. As I said, I just had a chance to sit down with 8 other Western states, and we got together, and this is some of the data. I mean, right now, a lot of states are using dissolved oxygen as a translator to try to establish the phosphorus limit. Chlorophyll A, there's been a lot more success with, because there is a consistent reaction and relationship between the levels of chlorophyll A and phosphorus and nitrogen. There are some phosphorus, but there, as you see, we've tried a variety of different stress response relationships so we can try to establish nutrient inputs. What's happened is we've ended up with a wide variety. Some states don't have numeric water quality yet. They have narrative water quality standards for nutrients saying shall not cause odor, shall not cause excessive algal growth, shall not cause fish kills. But then that's pretty qualitative, especially when algal growth. Well, how much is too much? You know, we've got some pictures. Clearly, it clogged the entire stream. That was too much. But as you can see, 80 EQs, ours historic single sample max, which was established back in the 1980s, is considerably higher. California's got a pretty high rate. As you work your way down, we've recently done some really hard work trying to do diatoms and measure that as a stress response and macroinvertebrate assemblages, which has brought that total phosphorus range down, although we haven't got these. We're rethinking it because our data had some issues with it. But Colorado's got one dialed down, Montana, ecoregions, they use ecoregions. But if you get down and look at the bottom, you see that US EPA recommended ecoregional data, and you can see everyone's quite a bit higher than that. Now theirs is based on good science. It's cause, effect. But as you can see, getting down to that level is very challenging. And we're also responsible to the people in our state. We can't create regulations and standards that aren't achievable because that's not setting up for success. So we realize that we have some problems in the West. The big one is there's a lot of phosphorus out here in the ground. You notice mostly, and this will relate to the next coming slide. You can see Arizona, we've got a great deal of phosphorus in our soils, not so much as in the Northwest, but certainly there's only a few pockets of phosphorus found in the soil profiles in the Midwest and East, although it does have some hot spots. So you look back, okay, which ones do have total nitrogen, total phosphorus standards? As you can see, almost none in the West have nutrient, numeric criteria. We do have, like in Arizona and the other states, have numeric criteria on some water bodies. Like the ones we put in 1987 were basically put there to protect our major lakes. The other states are the same. They only apply numeric where it's direct tributary to a lake. Obviously, that makes it a little bit more difficult. In general, we are all in the same boat. Pardon me. Now, with chlorophyll A, as I mentioned, we're having a lot better luck. Colorado and Oregon have set statewide standards that seem to be working. They're both very recent. Of course, continued monitoring of a part of that, like Colorado, and I worked there for 10 years, so I'm pretty familiar with their program. They still have not adopted numeric nitrogen and phosphorus data, but they got that on a 10-year roadmap to get there. But there's always lack of data. It never seems to, and I've heard that reflected here already. There's never enough data. And so we got to go out and get more and try and capture all the right data. Well, what was the temperature when that sample was taken? What was the water temperature? We usually do catch water temperature. We don't air temperature. What was the conditions leading up to that? Was there a runoff event? How long was the antecedent when there was, as I saw in EPA's, we in the Southwest have a problem with atmospheric deposition of phosphorus. Well, the longer it doesn't rain, the worse it gets when it does. So how can you measure that and quantify that in a standard that would be protective, but not overly protective of human health and the environment? Just for an example, and of course I'm going to pick on Arizona because that's what I've been working on lately. These are EPA's ecoregions for their standards, which if you remember are the xeric is 0.02 and mountain is 0.01 milligrams per liter, and remember ours is 0.2 to 1 range, which is we consider okay. So you can see there's a little disparity between what EPA wants us to do and what we're doing. But we are working on it, promise. So one thing we got to do is make sure we don't set a standard that's not achievable, and you did see the amount of phosphorus in our background, atmospheric deposition, soils, the standards here. If we, one of my great our heroes back there was able to do some R coding and gave me this graphic. And this is just based on existing water chemistry that we have now and phosphorus loads. And if you notice, the bottom two icons, the larger of the circles, exceed EPA standards. So you say the quick analysis of all the water quality samples we've got for phosphorus, we exceed just about everywhere. So setting that standard and being cognizant of not creating unnecessary fiscal burden on the point source discharges, not to mention how do we control the non-point source? I mean, that's what everyone's struggling with, really. In the absence of a lot of agriculture, we have very few CAFOs or AFOs in our state, so it's not a contributor. Ours are natural background, so to try to put the impetus on the wastewater treatment plant dischargers to meet these standards alone without non-point source rules, and it doesn't make much sense. I mean, we don't want to beat industry over the head and get them to comply. We want to make it possible for them to comply and work more holistically so we can actually address the problem together in partnerships. So, and we are not alone in the Western states. Like I said, we all got together in December and we thought somebody would have an epiphany amongst us, and we realized we all have the same problem. It's the natural background, it's non-point source. It's all the other issues we have. California did give us a little hope, although their approach is totally different. They, as you notice, still haven't set numeric limits. But what they do on a watershed basis, they determine the load for that watershed, and then they share it amongst the dischargers. There are some of them more financially capable to be able to treat it to a higher level as some maybe smaller dischargers. So they're doing trading. So that's one of the creative things. Rather than setting a standard, say, well, let's just go do what we can to try to address the problem. Let's reduce the inputs where we can and help those who we regulate achieve those goals. And in general, that's kind of what's going on, is that rather than relying on a regulatory approach, most of what we're doing now, and I'm about to propose this here in Arizona, is we go to a watershed-based nutrient reduction program, where we can have these components of prioritize the watersheds where it's a problem. Set load reduction goals, and evaluate the effect of point source permits, but also incorporate, we're going to should have closer partnerships with the state ag agencies. I do know when I started in Wyoming, we had a very close relationship with the NRCS and the Wyoming Department of Ag, and that's how we addressed a lot of water quality issues. The NMP reductions for smaller non-MS4, I don't know if you know that, if they're smaller than 10,000 people, they are a non-MS4, but they still have wastewater treatment plant issues and discharge rate that they need to get some assistance. Then we got to start reporting. I saw that earlier. We don't know if we're being effective. Well, we don't. So an ongoing monitoring program annually and doing reports, embracing your stakeholders and the dischargers and like that to try to achieve The overall goal is just reduce the amount of phosphorus and nitrogen in the environment that creates undesirable conditions, including fish kills. That's about it. I mean, I don't want to wind our problems. We're not being successful. I'd rather wish we could say we were, but it's not just us. It's all in the West. And not just, there's other states back east, you know, they're struggling also. So that's the high overview of it. If you want to get me aside, I can talk standards for a week.
Thank you, Rick. All right, so I have let's give a big hand. You have anything? We're going to pull a question off our exciting electronic system. Go ahead, Olga.
So one of the questions is, do we have a good idea of the main causes of atmospheric deposition of phosphorus?
I don't, but I do know locally, a lot of it's coming from our wildfires. Because when the West burns up, all that phosphorus comes up and it falls back down on us, so. I know we have mercury problem with that deposition, and that's coming from the coal-fired power plants. I don't know how much of that includes phosphorus, though.
Other questions from the audience or coming online? Do we see any? Yeah, so one thing about the atmospheric deposition, yeah, so once you have a P-rich parent material, you're really in, it's really challenging, right? Because any sort of land disturbance or drying or, so a lot of this has to do with climate change impacts, right? Leading to soil degradation, loss of soil crust in the desert is going to contribute to phosphorus transport. And you're right, that's a hard problem to solve. Anything else anyone has? Yeah.
So I know it's difficult to set numeric criteria and things like that, and you've done a good job talking about that. Once numeric criteria, for phosphorus, let's say once they're set, what would be the impact of that on agriculture? And on other industries as well, but what's the true impact of once that's set? Because it seems to be a pretty important thing, but I don't know that I understand the full impact that would have.
Well, agriculture is a special snowflake in our world. We don't directly regulate agricultural discharges. However, we do try to work in partnership with them to help them address the issues. Like we don't issue permits to ag and CAFOs like we do wastewater treatment plants and the other point source dischargers. So it's really a cooperative effort that we promote and do a lot of monitoring for them. Of course, they use the water too, and they need clean water coming into their operations. So some of the designated uses are ag, irrigation, and livestock. So those are two standards that can be pretty tight sometimes so that they also have clean water to use.
Great. Anything else out there? Oh, there we go. I'll go on and run that over to.
I was just curious. Is there a discussion of how the criteria for nutrients or chlorophyll might change depending upon whether it's like an artificial water body like a reservoir versus a natural lake? I know that in North Carolina that sometimes is brought up as an issue when these criteria get debated.
Yeah, so great question. We're in that pretty deep right now. There's only one or two real lakes in Arizona, but we have hundreds of man-made lakes. So what we're doing right now is we're in the middle of a study trying to define the characteristics of our lakes and how they change. A lot of our lakes don't turn over, which does cause a problem with nitrogen and phosphorus, but we don't have that in a lot of them. So what we're trying to do is evaluate the models that EPA has recently come out with and see which ones might work for us in our different types of lakes. I mean, we do have big reservoirs that do turn over and act a lot like a natural lake, but we have many that don't. And the temperature, our water bodies get really hot.
All right, we'll do one more question before we turn over to our panel.
Okay, I have a question about the biotic ligand model,
Yes.
right? And is there any movement towards accepting that as a measure, an alternative to the more common regulatory measurements?
Well, we do use the biotic ligand model for our metals. It's not ideal because it requires a lot of inputs. rather than a one-to-one relationship. Then again, it's kind of like phosphorus, you're evaluating hardness, different levels of the pollutants that change that. EPA is doing some work now with the multiple linear regression model that doesn't require quite as much information data and is producing similar results to the BLM. And I think we will see a migration to that in the future as a better method of and we use that to set site-specific standards, which may end up what we're going to be doing with nutrient endpoints too, because local conditions really dictate whether that system it can have a higher level of phosphorus and still be healthy, which in another area would not work. So that's when we do start using models like the BLM and the multiple linear regression model to try to establish that site-specific standard.
Great, let's thank Rick again.